we basically, for the introduction to asphalt, don't really have a resource document. The copies of the PowerPoints will be available PDF version for you to download, as well as the specification books and so forth. You can download those from the two DOT sites. One of the basic books I've used for a long time in this class, you should see in front of you, it's called the Hot Mix Asphalt Paving Handbook. And it's a pretty good general description, particularly if you're brand new to the asphalt world or even the construction world. It's laid out in multiple sections. It was actually a joint document by AASHTO, the American Association of State Highway and Transportation Officials, the Federal Aviation Administration, Federal Highway Administration, NAPA, the National Asphalt Paving Association, U.S. Army Corps of Engineers, APWA, American Public Works, and NACE, the Association of County Engineers. So it's a broad-based group. But what's interesting about this book, and it is dated, you can see it's 2000, and that doesn't mean the year 2000, but a lot of the experts that wrote these sections, some of whom we've lost, obviously, in the last 20 years, but they're national, international experts, and they wrote these different sections, and they're really well done. There's a lot of expertise. 20 years has changed some things as far as specification, intelligent compaction, warm mix asphalt, all those things, but the basic tenets of asphalt paving and construction are the same. And so going down the line here, you can download this document for free. It's free shareware. The link is here if you want to screenshot this now, but you can also just Google Hot Mix Asphalt Paving Handbook 2000. And one of your links will probably be the Federal Aviation Administration, FAA.gov. And that's probably the quickest way to get it. If you go through the FAA, you'll get this page. And down below, it's in their advisory sections for you consultants that are used to doing airport jobs. Go ahead and download this document. And it's, like I said, it's public shareware. You can get it through other sites, but like even the NAPA site, which I'll show in a second here, but I think they may charge a nominal rate for it. But if you go in through the FAA site, you can download it down below. You can see you can download the appendices and the document. And I would urge you to do so. Whether you want to print it or not, I guess that's up to you. But certainly in tablet format or on your laptop, it's a good document to have. I go back to this, and I've had it for 20 years, including a CD version of it, if any of you remember what a CD is. And I go back to it all the time, sometimes when I get questions, or a lot of times I get called from lawyers on lawsuits or claims or issues, and I just send them the portion of that reference book. So it is available through, as I mentioned, through the NAPA website as well. So of course, the whole idea behind, and we'll get into the first section, is on quality control, quality assurance in the DOT world. But what we're after is good roads, and it doesn't matter whether you're the highway user, the contractor, the agency. We're after good roads. So as we get into it, kind of the layout of these 4 modules that we're going to run through today, we're going to start off with the 3 A's of asphalt. Asphalt's got a lot of slang and different terms: blacktop, mix, hot mix, and we'll talk about the asphalt mixture itself and kind of break it down into the 3 A's that come together to make a good asphalt mix. And then we'll start off in module 1 here with quality control, quality assurance, and independent assurance. And that's the method that we use to test, sample test, and accept asphalt materials and asphalt construction in the DOT world. And you might think, if you're a city or county, that, well, then this means nothing to me. Well, it does mean something to you, because the tenets, the basic tenets of QCQA, IA, you may, obviously with the city, probably not doing a 60,000 ton job, but there's ways that you can pull tenets from this QCQA system and put them into use for smaller jobs and limited jobs. And then we're going to talk about the asphalt binder itself in module 2. This is the liquid asphalt, so to speak. And then in the 3rd module, we'll talk about aggregate. And of course, that's, you can tell two of the A's already, right? Asphalt binder, aggregate. So we got two of the A's started. And then the last module, we're going to, I kind of call it three P's and the C. We're going to have the three primers, and then we're going to talk about pavement distress, project selection, production, and construction. The introduction to course is no longer a prerequisite with QCQA in either North Dakota or South Dakota with the DOTs, but it's good to have it on record. You'll be entered into the database as having taken and completed the course. And for those of you that are new and continuing through the certification process, you'll be going through, for example, aggregate testing later this year, asphalt mixture testing later this year, pavement or roadway inspection later this year. Those all require written tests for certification, and that you take them and pass them. But they also, for aggregate and mix, have a proficiency too to demonstrate the test procedures. The written examination for this class is more to get you on record and get you used to kind of how the questions are phrased, what they'll look like. You know, obviously an aggregate mix testing class, different subject matter, but you'll be used to those written tests. Kind of my background is I've been executive director with DAPA for 20 years. As I mentioned, I've been doing these classes for both DOTs for roughly that long. Prior to that, I was with the city of Sioux Falls. But for 20 years prior to that, I was actually with the Wyoming Department of Transportation in the materials lab in Cheyenne as a resident engineer in Jackson, and then as a district maintenance engineer in Casper. So got a pretty good background there from a DOT standpoint across a wide variety of things. And I actually I went to school at South Dakota State, but when I got out of school, graduated, I worked a couple years for Texaco, which is now enveloped into Chevron, if you're familiar with oil companies. So I was a project engineer in Houston for a couple of years. Who DAPA is, we represent over 80 contractor, producer, refiner, engineering firms, and other companies involved in HMA. And again, HMA in that nomenclature stands for hot mix asphalt in North and South Dakota. Essentially, our charter and the way we're set up is we're dedicated to quality asphalt construction through education and research and training, and that's what I do probably 95% of the time. So been involved with these bituminous certification courses. We also work with other agencies and with the LTAPs, both North Dakota and South Dakota local transportation assistance programs. And then I'm involved with a number of research jobs, particularly with through the DOTs on research panels, but also through South Dakota State University and University of North Dakota are the two primary participants at this time. Well, going to the three A's, essentially those three A's, we talked about two of them already, the asphalt binder and the aggregate. The third one is air, and I want you to think of air, and that's what we look at for mix control and mix design in the asphalt world is air voids. You've probably heard that before. And we design and control to that in the field. So air is really representative of the mix design itself. Is we need enough room in that mix for the asphalt binder to coat the aggregate, to become the glue that's in the mix, and to give expansion and contraction. But when we build that pavement and construct it, obviously we roll it or compact it, is we run and reduce that air as well, so that that mat becomes impermeable. So there's no interconnected air voids. So those are kind of the three A's I'd have you, particularly for those of you that are new in this world, to think about classifying the three A's of asphalt concrete. The first thing we have to, or next thing we have to get into then is what's called quality assurance. And it's called quality assurance because in the late 1990s, three significant technological and procedural breakthroughs were initiated to improve the performance and construction of asphalt mixtures and pavements. And I apologize for reading that directly. You can see it in front of you. But those three basically you can put into one of these categories. First was the introduction and specification adoption of a new asphalt binder specification, which we'll talk about here later this morning. And in normal terms, that's called the PG system, PG standing for performance graded. And we'll run through that here in a second. But that was a huge deal back in the late 90s, and it Took a while to gain some strength, get its footing. Probably not until the 2005, 2007, where both state DOTs were routinely using the PG binder specification. And counties and cities were still using some of the prior specification systems, and the oil supplier, asphalt supplier, was having to revert what you were requesting on your plan sheets back to the PG binder. In other words, making it kind of match two sometimes disparate specification grades. So pretty much in wide use now. We'll talk about that later. The second major push, again, about late 90s, was a new asphalt mixture design method called super pave. And for those of you that have been around a little while, you probably worked in the Marshall system, the Marshall mix design system. For those of you that came maybe from the federal side, the VEEM method, HVEEM, were predominant. Super Pave was a full circle mix design and control system, including specifications and test methods that was developed in the early 90s and adopted in the late 90s. And again, both states kind of, started rolling over into Super Pave mixes. And again, I don't want cities and counties to say, well, Super Pave, I'm just a western county here with 1,500 people and 150 miles of quote blacktop road. What do I worry about super pave? Well, it's the system. It's not, super pave applies to everything basically, and it's a very good system for designing and controlling mixes in the field. And without getting into too much detail, that was the second major item, was super pave. Super pave was an acronym for superior performing asphalt pavement, basically. The third, and just as important in my mind, was the introduction and adoption of a new method for field control and specification compliance called QC/QA, quality control, quality assurance. So I want you to think about this is, when you start in construction, one of the first things you kind of learn, regardless on which side of the line you are, contractor or agency, is how you're going to pay for this, right? And so, at some point, we don't work for free. We may think of it sometimes, but we don't work for free. Is how are you going to pay for it? Well, that requires sampling, testing, some type of acceptance procedure. And the quality control, quality assurance system kind of turned everything on its head to come up with a better way of doing this sampling, testing, and acceptance criteria. And so I want you to think of it first, and again, it's called QC/QA, kind of the slang term for it. But there's really three legs to it. QC, quality control, and you can see the C is in bold, is performed by the producer or contractor. So it puts the responsibility for quality control back in the producer's lap. And for those of you that are relatively young, that probably makes a lot of sense. But for myself, I've been doing this for 40 years. Back 30 years ago, guess what? The agency pretty much did all the testing, and in effect did the quality control testing for the contractor. And there were a lot of problems in starting out the relationship that way, particularly in our part of the world where we got thousands of different combinations of aggregate pits and quarries and mixes and so forth. So the first leg to the chair is quality control. The second leg, QA, the A is emphasized here, quality assurance, is performed by the agency, the DOT, the owner. So that's the second round of testing and acceptance. And then the third, and just as important piece of this, is IA. And again, the A emphasized independent assurance. And this is performed by an independent agency representative. And typically in North Dakota, that's going to be the District Materials Coordinator Office. In South Dakota, that's the Region Materials Engineer Office. So that's a third leg. The way I kind of always lay this out in class is if you look at it from a perspective standpoint, if you're looking at a cornfield, QC is the guy walking the rows, checking every ear, checking the tasseling, and going row by row. QA is the crop duster plane, flying over at 80 to 100 feet and looking at 10 or 15 or 20 rows at a time. IA is kind of from photographic surveying. They can see not only that cornfield but the soybean field next to it. And in case you're wondering, the fourth leg of this program, QCQA, is actually having good specification, sampling, and testing criteria. And so we'll get into that briefly here as well. So QCQA and asphalt production, again, it's the acceptance or compliance criteria we use now. If we go back and historically look, there were kind of 4 different methods of accepting materials. End result, which stresses testing, not inspection. That would be similar to like structural steel or rebar, where you're actually getting a certification document that's based on a test, whether it's tensile strength or yield strength. QA, which we're talking about now, there's a movement to performance-based specifications, but typically with performance-based specifications, particularly in the highway or transportation infrastructure world, you're talking about warranties. And then the old method that we used prior to QCQA in the asphalt world was really a method spec, a recipe spec. In a method spec, you're just kind of looking at basic properties of the materials. You're looking at the recipe or the mix design, and if the mix design fits, guess what? It's accepted in place in the field. And there were some problems with that. So with that rolled out again in the late 90s was the Federal Highway Administration, the federal government, because a lot of our roads are built obviously with federal aid funds in the Dakotas and across the upper Great Plains, northern Rocky Mountains particularly, on all projects on the NHS being the National Highway System. You can see it's actually in the CFR, in the National Codified Regulations or laws. And its implementation was to begin in 1997, which it did. And in this, if you go into CFR, under quality assurance, it states its purpose is to assure the quality of materials construction in all federal aid highway projects on the NHS. The 7 elements, kind of basic elements of the QA program, starting with the 3 core elements, which I already kind of talked about: QC, QA, and IA, contractor quality control, agency acceptance, and agency independent assurance. And then that 4th leg of the chairs is the specification and testing criteria. But the other ones are built within a QCQA, which is a lot of people don't recognize, is a natural and flowing dispute resolution. If there's an issue with materials, you can trace them back. And primarily it traces it back so that you determine that it's not a problem with testing or reporting, it's an actual problem with the materials. The next one is laboratory accreditation and qualification. For example, the South Dakota DOT lab I'm sitting in here, as well as where Sharon's at the North Dakota DOT, they go through a relatively rigorous accreditation program called AMRL, Asphalt Materials and Reference Laboratory, where they do round-robin testing on blank samples, as well as get inspectors in, which I believe was done virtually this year, to check them out. And then the last element is the personnel qualification and certification, which is the reason and the need for the QCQA training that we're sitting in today. Starting off with that first one, quality control is just the system used by the contractor to monitor, assess, and adjust processes to ensure that the final product meets the level of quality. Under a proper quality assurance program, this is assigned to the contractor, and in the Dakotas it is. And this is very important because in our part of the world and the way we do business with multiple different material sources is the contractor knows their plant, they know how they bid the job, they know what materials they're bidding the job with, so they need to manage their own quality control to come up with an acceptable end result product. Those key activities for quality control are in the materials production and transportation. As I mentioned, it could be long dry haul from aggregate pits a ways away, or with quarried material that's brought in or imported in, and also with the field placement processes, and this is from plant to paver to compaction. And then with that, obviously, the responsibility comes the testing and affirmation part, so it includes sampling and testing, inspection, and obviously the material storage and stockpiling for our larger type projects, since we have a compressed construction season. On the agency side, the QA is the key point to remember is that all acceptance decisions are made by the agency. And in most cases, this is the DOT. They're the ones that sign the progress payment. They're the ones that cut the check. So The CFR says the contractor QC data may be included in the final acceptance determination, and in both North Dakota and South Dakota it is. The contractor QC data is used in the acceptance. The primary QA activities are monitoring the QC work by the contractor, as well as it can be independent or split sample testing and testing of the materials involved in the construction process, as well as their own inspection. And basically, if you put these into 3 words, it's evaluating product quality. And when I do the inspection class, it's called roadway inspection in South Dakota, pavement inspection in North Dakota. Is basically the same class. You know, that's one thing we talk about, is we can test the material all we want, but when you have obviously defective material as a finished result, that's a check mark against product quality. Just a couple of little background things here. For both North Dakota and South Dakota, in Super Pave in North Dakota, the standard specification is in section 430 of the spec book. And basically there's 6 traffic levels from FAA 40 up through FAA 45. Those are their Super Pave mixes. The traffic levels from left to right go from low traffic volume, say CF County Farm to Market type roads with an FAA 40, till you get to an Interstate 94 or 29 or a US 83 or US 2 between Minot and Williston is on the FAA 45 side of the scale. And basically, as you go up the ladder there, you're increasing the specification requirements, raising the bar, so to speak. In South Dakota, the DOT standard specifications are actually termed gyratory controlled instead of Super Pave. We'll get into that in a second. But it's called same thing, Super Pave, and it's in section 322 of the standard specification book. And there's 5 traffic levels from Q1 up through Q5. Same basic rationalization. Q1 is a low traffic volume, Q5 is a high traffic volume type mix. Both utilize gyratory prepared specimens, meaning we use the gyratory compactor, sometimes called the Super Pave gyratory compactor, to prepare our specimens, both for evaluating field sampled mix, but as well as the mix design development prior to the project starting. Both sides, the DOT more and more, roughly about 50% of the mixes that are produced by the DOT now include the use of RAP, or recycled asphalt pavement. So recycled asphalt pavement is 100% not just recyclable, but reclaimable, meaning you can use all of it back in its original intended purpose in a pavement. And so we use that back into our mix. I call it kind of black rock. It's both aggregate and asphalt when we reclaim that roadway. So you'll see these traffic level monikers for Super Pave or gyratory controlled mix with the suffix of an R on there to denote that they're using recycled asphalt material in it. The predominant specification since roughly 2007 in both states has been Super Pave. South Dakota calls it gyratory controlled rather than Super Pave because it's a modification of the traditional Super Pave method. As I mentioned, Super Pave was developed as a full circle design, testing, specification system. Marshall was just a test apparatus. It was a hammer and a mold to prepare your specimens. Super Pave is a lot more than the gyratory compactor. It's aggregate requirements based on traffic. It's testing procedures. It was actually new aggregate requirements. And with those and their designated traffic levels, they didn't match South Dakota. So South Dakota started revising, modifying some of those traditional specification requirements under a strict, quote, Super Pave method to adjust to conditions that are specific to South Dakota, particularly traffic level and aggregate properties. So just remember that South Dakota calls it gyratory controlled, primarily just because they modified the dictated Super Pave requirements. First thing to kind of think about in QC/QA is we do a lot more testing. You know, that at first that's maybe considered a downside to it. It takes more work, takes more people. But you know what? If you're spending $125 million on pavements every year per state, probably a good idea that we do a little more testing. And so that was one of the first things that came about, was we increased the sampling and testing to make sure the performance properties are met. And one of the keys to that is what's called random sampling. And all that means is that any portion, whether it's aggregate going up the cold feed belt to the hot plant, or it's pavement behind the paver after it's been compacted, and before it's laid through the screed, has an equal chance of getting selected for testing. And if we don't have random, what happens is bias is introduced. And what we want is a judgment on the entire, whether it's a 10-mile job or the 20-mile job, what's the quality level. And so I didn't get this change in, but basically both states, South Dakota has a test method, 312, that has the random number generation. I can't remember the exact allocation. It's been kind of changing here, but on the North Dakota DOT side, same thing, random number generation, but I think it's in the field sampling testing manual appendices. Basically, random numbers are exactly as described. If you look at this list of paired numbers, 2-digit numbers, there's no way you can write an equation that's going to tell you what the next number is going to be, going right to left, left to right, up or down. And so you're going to go into these random number generation charts, and that's going to dictate your sampling time or location based upon the sampling frequency. So if we look at where this red box, you can see some paired numbers. Doesn't matter. You just go in independently in any place in this random number table. Start going left to right. Just stay consistent, or up and down. If you need one number, obviously your first one's 0.65, next one's 0.51. If you're looking at, say, cores behind the paver, you'd need two pairs of numbers. So the 0.65 might be your length into that sublot. The 0.51 might be the offset or the width into that sublot. So again, up or down, doesn't matter. Just go in a consistent direction. One last thing here now, with most of the tools being app-based, there are random number generator apps out there. The only thing you need to be assured of is that they meet the ASTM requirement, and there is an ASTM, American Society for Testing Materials, a specification for random numbers. If you think that's overkill, there's also one for salt and for water as well. So, but we use random numbers in aggregate sampling and testing, and in asphalt mixture sampling and testing, and then ultimately when the pavement's completed, for core locations to determine density or compaction criteria in the pavement. So in pure random sampling, this lot, 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 generally is considered in North Dakota to be called a day's production. In South Dakota, it's defined as 5,000 tons of mix to the main line, basically mix. And so that's the entire lot we're accepting, or looking at testing, sampling, testing, and accepting. And if you're using pure random sampling, you can get what's called bundled samples, and so each area has an equal chance of getting selected, right? And in general, they'll be spread out, but since it is random, you can get this kind of bunching criteria too. And these clustered samples can be a problem. One of the reasons why is it's more of a logistical issue, particularly with aggregate sampling and mixture sampling. If your first 4 samples in a 10-mile or 8-mile run day are in the first mile, you essentially overwhelm the field lab and even the sampling system, and that can create errors. Just from a human nature standpoint. The other thing is you generally like to have it spread out, so you can also use those samples for quality control, not just for acceptance. And so having them spread out over the entire day allows you to make, if you remember the terms, monitors and adjusts the process. That's what we're looking at. So both states utilize what's actually called stratified random sampling. And all that means is that we take the lot, the entire amount we're accepting, whether it's a day's production in North Dakota or a defined 5,000 ton lot in South Dakota, and break it down into smaller pieces, into sublots. And then we still use random sampling within those sublots. So you can kind of see in this area, just kind of a visual or graphic demonstration, this would be the South Dakota version, is you'd break the sublot into 1,000 tons, and that's in the specification. Then within that 1,000 ton, we use a random number generation to determine the time for mixture and aggregate sampling, or the location of the cores for density compliance. In North Dakota, a sublot is 1,500 tons. So, and again, the lot definition is a day's production. So that's going to give us a little better control and spread out that testing a little as well to eliminate any errors from just getting overrun. The goals and success of the QC/QA are pretty self-evident. As I mentioned before, its goal was to improve pavement quality, improve pavement performance. And in my, I guess, experience, you get what you measure. It doesn't matter whether it's asphalt pavement or anything else. You know, if you don't measure it, you're probably not likely to get it. And if you don't state what you want, you're not likely to get it either. So in the asphalt world, we're kind of looking at aggregate as far as physical descriptions, you know, size of the aggregate, maximum size, and the qualitative requirements of the aggregate. You know, how much shale is in it, how much is it rounded versus fractured, and so on. On the asphalt binder side, the asphalt cement, we talked about that a little bit already, is performance graded specifications. And then on the mixture itself, we're going to look at stability and durability. And then on the pavement, finished pavement itself, besides the compaction or density that I kind of briefly talked about with coring, we also look at ride quality. Is how smooth is that ride? International Roughness Index, IRI number. So why do we utilize it? I just want to throw a couple slides in here really quickly that kind of put the heels into QC/QA. This data is actually from 2016. Blair Lundy, who's retired now, but was the pavement management manager for South Dakota DOT, had put some data together. It was actually in anticipation of the Senate Bill 1 in South Dakota, which was a bill to improve or increase the amount of monies, state monies for transportation funding. And what Blair had done, and this was kind of an offshoot of it, was with the pavement management system, you know, you got years and years in data on different sections, different ages, different materials types, in different parts of the state. And as I mentioned, kind of the late 90s were the watershed event, those three major things that happened then. And so what Blair had done actually, in central South Dakota is used because it's primarily sand and gravel pits. Any quarried material has to be imported either to the west from the Black Hills and limestone quarries, or from the east from quartzite quarries or granite quarries in the northeastern part of the state. So it's kind of, I don't want to call it the lowest common denominator because the Mitchell or the Pierre area office and region will kick my butt, but it's got the most challenging job, let me put it that way, from an aggregate standpoint. So what this data represents was, this was done in 2013, 2014, so 14 years old, was all the pavements prior to 2000 in the central region. You could look at the data on how it performed. Every year, you know, what was the cracking index? How much was it rutting? How much was it raveling? What was its basic condition, pavement condition index, PCI? So you had data representing multiple miles, multiple projects, different years. And then post 2000, the year 2000, which again follows into the super pave PG binder QC/QA era. And if you looked at that, there was a drastic thing that stood out. And I think this is the most under-touted data in both DOTs, and in my experience, was that the post-2000, about 1/3 of those were resurfaced by the year 14, or at 14 years of age. So in other words, some type of overlay or mill and fill. Post-2000, only 7% of those miles of road were resurfaced by year 14. That is a huge improvement when you consider the amount of money involved with constructing and maintaining pavements. And if you multiply that across, you know, 77,000 square miles in South Dakota, 76,000, 75,000 plus in North Dakota, that's huge. That is literally millions of dollars a year. And you know what? In 5 or 10 years, those millions become billions. So one of the greatest untold stories, and it's not my data. So if you want to graph it out, and this is Blair's graphing, the red here, the bottom line, the red one is 1996. And this is a graph of pavement condition index, or how good a condition that pavement's in over time. So on the vertical axis, you go from 0 to 5, 5 being a perfect condition pavement, and 0 being literally total destruction. And you see that with the blue line, it stays pretty flat. You know, it starts out at, both start out at about 4.8, 4.9 after new construction. And the blue line, you know, you're still down at only at 4.2. I mean, it's still in great condition at year 13. Whereas the red line at about year 11 really starts diving down. So that is a perfect example of how these three things came together to improve pavement quality. So Dave Huff, who's the research manager with South Dakota DOT, went, I think it was TRB last year, Transportation Research Board meetings in Washington, D.C., either last year or year before, actually called me, and I had put this kind of data together off of Blair's presentation and presented it nationally. So just kind of narratively is the increase in average surface condition is 0.9 at year 3. And again, that's on a 5.0 scale. And if you look at the pre-2000, all at year 13, they were essentially in fair condition by general ranking, and post-2000, we're in very good condition at year 13. So if you run the numbers and just do the projection, that's about 4.5 years of extended life. And a lot of this comes about because QC/QA, because we're testing, we get what we measure. And so we're trying to measure and test what we're aiming at, and we're getting better criteria. So that kind of closes off this first module. I think we did have one question. Thank you, by the way. It basically had to do with the amount of testing that needs to be done. I'd mentioned with QC/QA that it does increase the testing, particularly compared to what we were doing before. Kind of depends on where you're at on those legs of the stool or chair. If you're on that first leg, quality control, you're going to be busy, really busy all day. And in a lot of cases, most QC labs have 2 people, 2 certified testers working. And to put it in perspective, for example, South Dakota sublot's 1,000 ton, North Dakota sublot's 1,500 tons. Well, in our part of the country, and we'll talk about this afternoon, is primarily DOT projects are done with drum mixers, with drum plants. And a drum plant is a continuous mixer, and under the right conditions, I've seen production rates up to 650 tons an hour, sometimes pushing 700. On average, if everything's going good, probably 400, 450 ton an hour. So do the math. You know, we have a limited construction season from May until October. And particularly in the middle of that season, when you have a lot of hours of sunlight, you know, it's 6 days a week sometimes, from 6 in the morning till 8 o'clock at night. So a 14-hour day times 500 tons an hour is 7,000 tons. Divide 7,000 by 1,000 or 1,500, and that's 4 or 5 sublots at least. And so with each of those 4 or 5 sublots, you're pulling not only an aggregate sample of the aggregate coming into the plant, into the drum mixer, but you're also pulling a mix sample out in the field. So you have a full range of aggregate that has to be tested depending on the state. You know, gradation, we'll talk about that here in a minute. Gradation, lightweight particle test, fine aggregate angularity test, sand equivalent test, all of those things. So you got to test in the lab. And then the mix itself, the asphalt mix itself, when that gets back to the lab, you're going to run what's called the Rice test, or maximum theoretical specific gravity or density. And you're going to pound out gyratory specimens to evaluate the third A, the air part, the volumetric property part. So when you add all those together, it's a busy process. So that's quality control. Quality assurance, as I mentioned before, they're kind of a level higher. You know, they're in the crop duster plane, not in the rows of corn. So their scheduled testing frequency is less, but their testing is just as important, because then we compare the testing's done on the same population. So the test results are compared between the two sources, QC and QA. And so if there's an issue there, that can get pretty busy in the QA lab, but from a materials handling standpoint, QA is a lesser, depending on the state and the particular property, it might be 1 per 5,000 tons or 1 per 10,000 tons, or North Dakota, sometimes the QA testing frequency is 4 out of the first 10 quality control tests. And then IA is the least amount on a particular project. In some cases, depending on the state, it might only be 1 or 2 samples that they have to test per project. But guess what? They're doing it for every project in the region or district. So it multiplies pretty quickly. So it is really busy. When the plant's humming and the conditions are dry and the stockpiles are low on moisture content, those plants can put out a lot of mix. And the higher the production of the mix and the more efficient it is, the better the price is going to be as well too in the long run. So hopefully that answers that question.
Ken, we had one more question too.
Okay, what was the question?
I know he's from North Dakota, but does a day's production take precedent over for sampling when tonnage isn't met for a lot size during paving of HMA over a number of project days? So I'm going to guess it's crossovers or some unique projects you're kind of asking.
And that obviously does happen. You can get a rain out, you can get a bad weather stop, you can get a equipment breakdown. We'll get into that in a lot more detail in the aggregate testing and mix testing classes, and I'm not trying to avoid the question, but it's pretty specific by state. And I really don't want to get into that, but to give you a rough idea, I guess, which an introduction class would do, is that there are procedures in place. In some cases, that day's lot is rolled over into the next day. In other cases, depending on how far you got into production that day, it'll be cut off, and that day will be considered, in South Dakota, for example, if you're into 4,000 tons, that day is considered its own lot. But it's really specific on the specification and it's specific state by state. So hopefully that answers the question.